Your body won't be the same by the time you get to Mars, said by the scientists. In the coming decade, in 2033, NASA and China intend to send astronauts to Mars for the first time in history. This presents numerous challenges, ranging from logistical and technical issues to ensuring that astronauts can deal with waste and have enough food and water for the months-long transit to and from Mars. But of course, there's also the health and safety of the astronauts, who will be spending months traveling through space where they'll be exposed to cosmic radiation and microgravity. There are even concerns that after months of exposure to microgravity, astronauts will have trouble adapting to Martian gravity. To determine if these fears have merit, a team of space medicine experts from the Australian National University, ANU, developed a mathematical model to predict whether astronauts can safely travel to Mars and perform their duties once they arrive on the red planet. This model could be immensely valuable alongside all the other preparations that need to happen before astronauts set foot on Mars. It could also be used to assess the impact of short and long-duration missions that take astronauts far beyond low Earth orbit, LEO, and the Earth-Moon system in the future. The paper that describes their mathematical model and conclusions recently appeared in NPJ Microgravity, a scientific journal published by Nature. The research team was led by Dr. Lex van Loon, a research fellow from the ANU College of Health and Medicine, CHM. As he and his colleagues note in their study, the potential hazards for missions bound for Mars are numerous, but the greatest threat is arguably the time the astronauts will spend in microgravity. Combined with damaging radiation from the sun and cosmic sources, the experience will cause fundamental changes to their bodies. Based on extensive research conducted aboard the International Space Station, ISS, microgravity is known to cause muscle and bone density loss and affect organ function, eyesight, and the cardiopulmonary system, the heart and its ability to pump blood through the body's system of arteries and veins. As Van Loon described in an ANU news release, their research is not only essential because of proposed missions to Mars, but for the burgeoning commercial space sector as well. We know it takes about 6 to 7 months to travel to Mars, and this could cause the structure of your blood vessels or the strength of your heart to change due to the weightlessness experienced as a result of zero-gravity space travel. With the rise of commercial space flight agencies like SpaceX and Blue Origin, there's more room for rich but not necessarily healthy people to go into space, so we want to use mathematical models to predict whether someone is fit to fly to Mars. Co-author Dr. Emma Tucker, an astrophysicist and emergency medicine registrar, added that prolonged exposure to zero gravity could cause the heart to become lazy because it doesn't have to work as hard to overcome gravity and pump blood throughout the body. When you're on Earth, gravity is pulling fluid to the bottom half of our body, which is why some people find their legs begin to swell up toward the end of the day. But when you go into space, that gravitational pull disappears, which means the fluid shifts to the top half of your body, and that triggers a response that fools the body into thinking there's too much fluid. As a result, you start going to the toilet a lot, you start getting rid of extra fluid, you don't feel thirsty and you don't drink as much, which means you become dehydrated in space. This, says Tucker, is why astronauts returning from the ISS are seen fainting when they set foot on Earth again or need to be transported using wheelchairs. The longer they stay in space, the more likely they will collapse when they return to Earth, and the more difficult the process of readjusting to Earth's gravity. In the case of the NASA twin study, Mark Kelly spent over a year in orbit and experienced terrible pain, swelling, and other symptoms upon his return, as he described in his book Endurance, A Year in Space, A Lifetime of Discovery. When it comes to missions bound for Mars, there's the added complication imposed by the communications delay between Earth and Mars. Depending on the alignment of the Sun, Earth, and Mars, these delays can last as long as 20 minutes, which means astronauts must be able to perform their duties without immediate assistance from mission controllers or support crews, which includes medical emergencies. As Van Loon explained, if an astronaut faints when they first step out of the spacecraft or if there's a medical emergency, there'll be nobody on Mars to help them. This is why we must be absolutely certain the astronaut is fit to fly and can adapt to Mars' gravitational field. They must be able to operate effectively and efficiently with minimal support during those crucial first few minutes. Their model relies on a machine learning algorithm based on astronaut data collected from past expeditions aboard the ISS and the Apollo missions to simulate the risks associated with traveling to Mars. Testing showed that it could simulate key cardiovascular hemodynamic changes after prolonged spaceflight and under different gravitational and fluid loading conditions. And the results are encouraging, as they indicate that astronauts can function after months spent in microgravity. While the current model is informed by data derived from middle-aged and well-trained astronauts, the researchers hope to expand its capabilities to include commercial spaceflight data. Ultimately, their goal is to create a model that can simulate the impact of prolonged space travel on relatively unhealthy individuals with pre-existing heart conditions, in other words, untrained civilians. They hope this model will provide a more holistic picture of what would happen if an everyday person were to travel to space. Further refinements could be made to incorporate age-related health issues, which would make sense given the number of celebrities that have flown to space recently: Wally Funk, William Shatner, Laura Shepard, Richard Branson, etc. Who knows? Perhaps it will be possible to simulate the effects of long-term exposure to microgravity on children and fetal development. This research is crucial if we ever want to send humans to the Moon, Mars, and other destinations to live someday.